Hi, good morning, students. Today we are going to see what is abstraction, our second lesson in higher secondary computer science textbook. What is abstraction? That's what the concept what we are going to see today. So first let us see a small description about what is abstraction. So abstraction is one of the key concept of object-oriented programming languages. Its main goal is to handle complexity by hiding unnecessary details from the user. That is very generic concept that is not limited to object-oriented programming. You can find it everywhere in the real world. So here, uh, it's a concept where we find everywhere in the world. It is hiding unnecessary detail from other persons or showing the real world only what is necessary, not everything what is unnecessary. Suppose you are going to an ATM to withdraw money. You simply insert your card and click some buttons and get the money. You don't need to know their background process. Is it? It's a simple concept that when you go to the ATM and you insert the ATM card and you withdraw the money, we never think about what happens in the ATM machine. Inside it or as a back-end process, what happens, we never bother about it. Let us see an example for data abstraction in Python. So here there is a simple program for defining the calculation. A small calculator program is given here. So you can see two variables x and y which gets the input from the user. The first input is collected by x and second input is collected by y, and we have four options. What is to do with the uh, values, that is addition, subtraction, multiplication and division. For all the four arithmetic operations we have four different functions: addition, subtraction, multiplication, division. Four different functions are given to perform the arithmetic operations. So here we never see what is happening here behind the screen. So each time when we select an option and addition is performed, when we press 2 subtraction happens, when we press 3 multiplication happens, and when we press 4 division happens. This process happens behind the screen, or it is known as the backend process. So now when we run this program, first we have to save it, and when we run this program we can see only the important informations, whatever is necessary to be displayed, is shown here. Enter the first value. So when we enter the first value 25 and enter the second value, after pressing the enter key you enter 65, you have an option to choose first addition, subtraction, multiplication, division. 1, 2, 3, 4 are the options which are used for selecting. So here I choose 3, so it's multiplication. So 25 divided by 60, sorry, multiplied by 65, you get 1625. So here already we have seen what happens behind the screen, that is these functions. These are hidden from the user. One who is using it never bother about what happens behind, what is the actual process happening behind. So data abstraction is nothing but hiding the backend process from the user and providing only the necessary information to the users. The next topic what we are going to see is about abstract data type. Constructors and selectors. Constructors are those functions that build abstract data type, and selectors are those functions that retrieve information from the data type. Retrieving the information from the constructors are done by selectors. So whatever information we give in the constructor is retrieved by the selectors. So those constructors which are created by abstract data type are used for hiding the unnecessary information. Here we have an example for abstract data type. We take it as city, and city is an object which holds city name, latitude and longitude. So here, to create a city object, use a function like city equal to makecity name lat long. To extract the information of the object city, use the function like get name city, get latitude, get longitude of city. So get name is a extract function. Get lat, get long is a extract function to get the information from the city, the constructor. So here is a pseudocode to compute the distance between two cities as objects. Let us take the function as distance city 1 comma city 2 latitude 1 longitude 1 equal to get latitude city 1 get longitude of city 1 get latitude of city 2 let longitude of city 2 is a function. Here we have a written formula is given there, which is used for finding the distance between two cities. So here we have the functions as get latitude, get longitude of both the cities. So here LG1, LT1, LT2, LG2 all are functions, parameters. So LT1 comma LG2 equal to get latitude city 1, get latitude of city 1. So we are getting the latitude and longitude of the city 1. So city LT becomes the value of the get latitude city 1. So here we get we collect the information, that is the values of latitude and longitude. Don't need to know how functions were implemented, assuming someone has defined them. So we need not worry about the functions which are already implemented. It is already implemented by someone else. The end user doesn't know how functions were implemented, but function is to be implemented by someone, defined by someone. It is already defined by someone. Get latitude, get longitude. All these functions were implemented by someone before. We need not bother about what is happening or how it was implemented and all those things. Here we can see identifying the constructors and selectors in the above example. So first we will see constructors. We have already seen that constructors are used to build the abstract data type. So here we have created an object city with the help of makecity. Makecity is the constructor. Makecity is the constructor. So in order to make a constructor, we can use a particular function. So here we have a display how the values are passed. Name, latitude and longitude are values passed as parameters. So makecity is the function. Here we have selectors. Selectors are nothing but the function that retrieve information from the data type. In the above code, we have seen that get name, get latitude, get longitude. These are the functions or selectors which are used for retrieving the information from the object city. So in order to retrieve the information as name, latitude, longitude of the city, we have a selector. All these are selector functions. So these functions will extract the information from the city, the object. So how the values are passed? City get name, we will be getting the name of the city. City get latitude, we will be getting the latitude. City longitude, we will be getting the longitude of the city. Identifying the constructors and selectors for a slope. So here another example is given. Constructors, this hyphens are used to mention as commands. So constructor, make point x comma y, return xy. So make point is a constructor, and x code point, y code, y coordinate, x coordinate and y coordinate are selectors, which is used to extract the uh, x coordinate and y coordinate from the uh, abstraction constructors. So data abstraction is supported by defining data abstraction type. The next topic what we are going to see is ADT, abstract data type. What is abstract data type? Data structures definition. In computer science, a data structure is a organization, management and storage that format that enables efficient access and modification. So what is a data abstraction? Data abstraction is how the informations are stored, how the data is organized, how can we access it, how can we modify it. All these things comes under data abstraction. So there are two ways of looking at data structures. One is mathematical, logical, abstract models or views. So this is one of the way how we look into the data structure, whether it may be in mathematical or logical or abstract or in view. The other one what we look into the data structures is implementation. How the data is implemented. So we may have some view or we may have some idea. How do we implement it? How the data are implemented? It is mentioned in abstract data type or how it is implemented, implementation. Definition for ADT. ADTs are the entities that definitions of data and operations but do not have implementation. So ADT, abstract data types, are definition of data and operations but actually they don't implement it. So whatever it may be, whatever data it may be or whatever operation it may be, it is only how it is defined. How can we define it? What all the entities needed, what all the objects needed, what all the operations needed, what all the data needed. All these things are mentioned or described in abstract data type. But all these things are only described, only defined, but not actually implemented. It is just like an algorithm. So we have already seen about algorithm. It is a uh, problem or written problem, how a problem can be solved. It's a process how the problems can be solved. So here we don't have actually a implementation in abstract data type. So here we have an example for abstract data type. So here we have an example for smartphone. We'll take an example a smartphone which consists of 4 GB RAM, Snapdragon 2.2 GHz processor, 5.5-inch LCD screen, dual camera, Android 8.0. So all these are abstract or logical view. So here we have some other options like call, text, photo, video. All these things we know that all these things are available in the smartphones. So we can make a call, we can send messages, we can take photographs, we can take videos. So all these things are the things which comes under the abstract view. So when we come to the the implementation view, you can see how the things are implemented. So here we have a class smartphone, and it is described as the RAM size, string, processor name, float, screen size, camera count, string, Android word. So all these things are mentioned with their particular data types. So and we have some functions which can be used for calling, making text, video, photo, all these things. So here this is the implementation view, how it is differing from the data abstraction or abstract view. So abstract view and implementation view are somewhat different. Abstract view is how we see it from the outside. When we see an object, how it looks like. Implementation is how it works from behind. Here is another example, data structure example. We have already seen about arrays. So here we have a memory box which is holding the values 10, 20, 30, 40. So in the abstract view, we can see store a set of elements of type integer. So integer type, how the values are stored. So here 10 is stored in the position position 0, and 20 is stored in the index position 1, 30 is stored in the index position 2, and 40 is stored in the index position 3. So here you can see that the abstract view, when we see the abstract view as store a set of elements of integer type, we can store the elements of integer type, that is only numerical values, that is whole numbers can be stored. The read elements by position, that is index. We have already seen in C++ that what are the examples, or what is the array, what is index position, and all those things we have seen. So how to read a element by its position. Modify elements by index. So if you want to make any changes, you can make the changes by its index value. Perform sorting. If you want to sort it, sorting means we know that arranging the values in some order. So this is abstract view. So this abstract view, how can we implement here? You see, this is a particular coding which we can give in the implementation. So abstract view is just knowing, or the backend, how it happens, what happens in the backend, and how we are implementing it, how the process is happening is in the implementation view. So I think you all understood what is abstract data type and these examples. So dear students, today we have seen what is abstraction, what is data abstraction, what is the use of data abstraction, how it is implemented, and what is constructor, what is selector. All these things we have gone through. So by this I wind up today's class. The remaining topics will be dealt tomorrow.